predator becomes prey in the Florida Everglades as hundreds of hunters descend on the Sunshine State to catch and kill as many Burmese pythons.
There is a moment in wildlife science when the data stops being numbers on a spreadsheet and becomes something you feel in your chest. It happened inside a dimly lit research room somewhere in South Florida. A team of biologists had gathered around a monitor, coffee going cold on the desk beside them, nobody speaking. The trail camera footage they were watching had been pulled from deep inside the Big Cypress National Preserve. The timestamp read sometime in the early hours of the morning. The swamp was dark, and what moved through the frame in the next 40 seconds rewrote everything those scientists thought they understood about where this story was heading. Nobody cheered. Nobody reached for their phone to post about it. One researcher pushed back from the table and stood at the window for a long moment before coming back to watch it again. Because what they were seeing was not a triumph, and it was not a disaster. It was something more complicated than either of those things. It was evidence that the Everglades, one of the most ecologically important and catastrophically wounded wild places in North America, was doing something nobody had engineered, budgeted for, or predicted. It was responding, and the response was messy, dangerous, and completely beyond human control. To understand what that footage means, you have to go back to the beginning of the wound itself. The Florida Everglades was never just a swamp in the way most people picture a swamp. It was a river, a slow, wide, shallow river of fresh water moving south across the limestone shelf of the Florida Peninsula, filtering through sawgrass prairies and cypress domes, feeding the aquifer that millions of people drink from, absorbing the violence of Atlantic storm surges before they could reach populated coastlines. Scientists have calculated the Everglades provides ecological services worth tens of billions of dollars annually, not through tourism or agriculture, but through the fundamental biological work of keeping South Florida habitable for human beings. The life inside it was staggering in its complexity. Wading birds in numbers large enough to block the horizon. American alligators in every waterway, performing the essential ecological function of digging water holes that dozens of other species depended on during dry seasons. Raccoons, possums, white-tailed deer, bobcats, and the rare Florida panther all moving through an ancient, layered food web that had been running without significant disruption for thousands of years. This was a system of extraordinary biological depth. And then something arrived that it had absolutely no preparation for. The Burmese python is not native to any ecosystem on Earth outside of Southeast Asia. It evolved over millions of years in a landscape that shaped it into something close to a perfect predator. Adults routinely exceed 15 feet in length and can weigh more than 100 pounds. Their scales provide camouflage so effective against dead vegetation and muddy water that experienced herpetologists standing 3 feet away have missed them entirely. Heat-sensing pits along their jawline allow them to detect the body warmth of prey animals in absolute darkness. They can remain motionless for days, submerged to the eyes in swamp water, waiting. And when they strike, the encounter is typically over before the prey animal has processed what is happening. How they arrived in the Everglades is a story of human carelessness compounding across decades. The exotic pet trade moved thousands of juvenile Burmese pythons into Florida homes throughout the 1980s and 1990s. A hatchling python is a remarkable animal, manageable and visually striking. What first-time owners consistently failed to account for was the animal it would become. A snake the length of a forearm becomes an apex predator taller than most humans within a few years. Overwhelmed and underprepared, thousands of pet owners made the decision that would eventually cost the Everglades everything. They drove to the edge of the wetlands and released their animals into the sawgrass. Hurricane Andrew in 1992 contributed additional animals when a reptile breeding facility near Miami was destroyed in the storm. The result across both pathways was the same. An unknown but substantial number of one of the world's most effective predators entered one of the world's most ecologically rich environments and found conditions that were essentially paradise. No natural predators. An unlimited supply of prey animals that had never evolved behavioral defenses against an ambush constrictor. subtropical heat that matched the python's native climate almost exactly. Dense, flooded vegetation that rendered human tracking efforts nearly impossible. The population did not grow gradually. It exploded. Current scientific estimates place the Burmese python population in South Florida somewhere between 100,000 and 300,000 individual animals. And the ecological cost of that explosion has been measured in numbers that remain genuinely difficult to absorb. Peer-reviewed research documented mammal population collapses across the Everglades that have no real parallel in recorded North American wildlife history. Raccoon populations in the hardest-hit survey zones dropped by over 99%. Opossum numbers fell by a comparable margin. Bobcat populations crashed by nearly 90%. Marsh rabbits and foxes in multiple survey areas were not depleted. They were functionally eliminated. Field biologists who had spent careers in the Everglades began describing something they struggled to articulate in scientific language. They called it the silence. Miles of habitat that had once moved with the constant activity of a thriving ecosystem, sitting still and empty and quiet in a way that felt profoundly wrong to anyone who knew what it was supposed to sound like. Florida's attempts to reverse the damage through direct human intervention tell a story of genuine effort running headlong into biological reality. The Florida Python Challenge, an annual public hunting competition offering prize money to registered participants, generated significant media coverage and introduced thousands of people to the scale of the problem. It also produced removal numbers that, measured against the size of the python population, were almost statistically irrelevant. Removing a few hundred snakes annually from a breeding population of potentially 300,000 animals is not a conservation strategy. It is a gesture. Professional contracted hunters, paid by the hour to work the levees and canal banks of South Florida, have performed far better. Thousands of snakes have been removed through sustained professional effort. But the math remains brutal. The pythons being removed represent a fraction of a population that continues to reproduce faster than removal programs can realistically operate. Thermal drone technology, which seemed promising in early trials, has proven largely ineffective because pythons are cold-blooded and the ambient temperature of the Everglades in summer makes thermal differentiation nearly impossible. Experimental lure systems designed to exploit the python's sensory biology have produced mixed results at best. The technology gap between what humans can deploy in flooded subtropical wilderness and what is actually required to meaningfully suppress a population of this size remains enormous. And then the field teams began reporting something that added a new and deeply unsettling dimension to the challenge. The pythons were not behaving the way they had in the early years of the hunting programs. Trapping sites that had produced consistent results were going quiet. Hunters returning to productive hunting corridors were finding nothing, not because the snakes had been removed, but because the animals had relocated into terrain that was nearly impossible for humans to access on foot. Researchers studying python movement data across multiple field seasons documented a consistent pattern. The snakes were not avoiding human activity randomly. They were systematically moving away from areas of human presence, deeper into the interior of the preserve, further from the access points that hunters depended on. Whether this represents learned behavioral adaptation within individual animals or a slower generational shift driven by natural selection, quietly removing the less cautious animals from the breeding population, the implication is the same. An animal that was already extraordinarily difficult to locate was becoming better at not being found. While the visible war between hunters and pythons was consuming most of the public attention around the Everglades crisis, something microscopic was moving through the ecosystem almost entirely undetected. It had arrived. With the pythons, it had been spreading silently for years. And when scientists finally mapped its reach, the picture they uncovered was in some respects more alarming than the python population itself. The organism is called Rhytiella orientalis, a parasitic lungworm native to Southeast Asia. Burmese pythons carry it and have coexisted with it long enough to develop significant biological tolerance. The native wildlife of the Everglades had no such tolerance, and no prior exposure. The transmission pathway the lungworm uses to move between hosts is one of the more genuinely disturbing things documented in recent American wildlife biology. An infected python deposits waste material in the swamp. Insects, primarily cockroaches, consume that material and pick up the larval parasites. Frogs consume the insects. Native snakes consume the frogs. Inside the native snake, the larvae migrate through the stomach wall directly into the lungs, where they attach, feed, and multiply as the airways progressively fill. The infection is slow, debilitating, and fatal. Researchers have documented native snakes in advanced stages of infection with the worms visible in their airways, too weak to feed, suffocating from the inside. The geographic spread of the parasite has far outrun the geographic spread of the pythons themselves. At least 18 native snake species across Florida have tested positive for the lungworm. The infection has been documented as far north as Jacksonville. And the most consequential finding of all is that the parasite no longer requires a Burmese python to propagate. It has established independent transmission chains between native species. Even a complete and instantaneous elimination of every python in Florida would not stop the lungworm now. It is permanent. There is, however, a single anomaly in the infection data that has become the most urgently studied question in Florida wildlife biology. The Florida cottonmouth, a venomous pit viper present throughout the infected range, is consistently testing negative. Across multiple survey sites and multiple field seasons, cottonmouths in habitats where the lungworm is widespread among other species show no evidence of infection. No worms. No respiratory symptoms. No tissue damage. Something in the cottonmouth's biology is creating an environment that the parasite cannot survive in. Researchers do not yet know whether the mechanism is immunological, biochemical, or something else entirely. But if the resistance can be identified, isolated, and understood, it could represent the foundation of an intervention that nothing else has come close to providing. Against this backdrop of compounding crisis, Florida wildlife officials announced a